Which equation has infinitely many solutions? Now, for an equation to have infinitely number of solutions, you will go through, you'll solve for x, and you'll get a true statement. If you get a plain number, it has 1. If you get a false statement, it has no solution. And if you have a true statement, again, it will be an infinite number of solutions. In other words, it doesn't matter what number you plug in, it will always be the same. All right, so for A, we have x is equal to 1/2, 1/4 x plus 3/4. And already you will notice that you're going to end up with one solution, because minus 3/4 x minus 1/4 x. So you get 3/4 x is equal to 3/4. And so the only answer is possible is 1. 1 times 3/4 is 3/4. This has one solution. So not the infinite number of solutions we're looking for. Let's look at the second one. So let's rewrite the problem. All right. So subtract 1/3 x minus 1/3 x. We get 1/3 x minus 5 plus 5 plus 5. So I get 0 is equal to 1/3 x. Well, what number times 1/3 is equal to 0? 0. So in this case, x is equal to 0. This is one solution, not infinite number of solutions. Therefore, that is not the right answer. So we can strike these two off our possibilities. Next one, 1/2 times 1 plus 4x equal to 2x minus 3. All right, so 1/4 plus 2x is equal to 2x minus 3. Okay, now right now you might be noticing that something weird is happening here. You have 2x on this side and 2x on that side. When I subtract 2x from both sides to try to get them together, I end up with 1/2 is equal to negative 3. This is a false statement, which means there is no solution. And that's because if I graphed this equation and this equation, I would end up with a pair of parallel lines that don't cross. Which leaves, obviously, D. But let's show you what happens with D. So we have 3 minus 4x is equal to negative 6 times 2/3 x minus 1/2. Negative 6 gets distributed, so negative 6, well, 3 goes into 6 twice. 2 times 2 is 4, so we end up with negative 4x. So negative 6 times negative 1/2 is positive 3. And right now you can tell that you have the same equation. If I were to add 4x from both sides, or to both sides, I would get 3 is equal to 3. This is a true statement, which means they are the same line, or you have the infinitely many solutions. And so D is our answer. It's important to recognize the distinction between infinite number of solutions and no solution. Again, true statement means an infinite number of solutions, false means none. Kurt jogged on a path that was 2 miles long, took a break, and then jogged back along the same path to where he started. You need to take a break after 2 miles? Craziness. He jogged at different speeds for different distances along the path as shown below. All right. Between which times did Kurt jog the fastest? Well, that's asking for our slope. And remember, it's distance from starting point. So in terms of speed, we don't care if it's a negative or a positive slope. We just want the quickest. So right here, he went 1 mile in 10 minutes. Oh my goodness. It's painful to think that someone ran 1 mile in 10 minutes. So his slope here is 1 over 10. We know that this cannot be right because it has a more shallow slope than this one, so let's not even bother with this. Here is his break time, no slope. So then let's take a look. Having fun? So here we went 2 miles over the course of 10, 20, 30 minutes. That's equal to 1 over 15. Well, 1/10 is bigger than 1/15, so clearly it's 0 to 10 minutes. Next page. Henry and Karen each sold food at the fair. The table below shows the total number of corn dogs. Oh God, really? People still eat corn dogs? Karen sold at different times of the day. Alright. Henry uses the equation below to show the number of hot dogs he has sold after tea hours. Which statement can you say is true? The rate. So, since all the questions start out with the rate, we know that the rate at which the hot dogs are sold is 14 hot dogs per hour. So, let's take a look here. We have a difference of 14, 14, 14. But that's every 2 hours. So Karen is selling at a rate of 7 corn dogs per hour. Which makes sense, because corn dogs inherently are kind of gross. I don't care how good they may or may not taste, they're gross. So, we know that Henry sold twice as many dogs as Karen. So the rate Henry sells hot dogs is half. No. The rate that Henry sells hot dogs is double the rate of Karen sold. Yes, that is true. Alright. Number 44. A group of 4 friends each mowed lawns after school and on the weekends for a month. The total number of lawns mowed can be represented by the equation below. Okay. So a group of 4 friends. So here's 1 friend, 2 friends, 3 friends. That's the 4th friend. Okay. Each friend is represented by a term in the equation. How many lawns, X, did the first friend mow? Okay. Well, the first friend is this guy right here. Just plain old X, which makes life much easier for us. So we have 1 plus 1/3, X plus 1/3 X plus 1/2 X. And so all told, so turning this into 6, so it's 3/6. This is 2/6. This is 6/6, right? That's 1. So we have 5/6 X plus 16 is equal to 49. Bless you. Minus 16, minus 16. So we get 5/6 X is equal to, okay, so that's 3. Alright. Alright, so then okay. Okay, so moving on. So we know that we have to have a number that is divisible by 6. That's the first thing we know. So let's go ahead and What's the opposite of multiplying by 5/6? Dividing by 5/6. Oh, it's not 5/6, it's 11/6. There's my mistake. Why is it 11/6? 6 plus 2 plus 3 is 11. Okay, now we're all good. So you may have noticed the pause. I knew that 5 does not go into 33, so I knew I had done something wrong, and so I was stalling to figure out what I'd done wrong. And what I'd done wrong is, this is 5/6 plus the 6/6, so that is a total of 11/6. So I'm going to divide everything, or multiply everything by the reciprocal, 6 over 11. And so that's just going to get me x. 11 goes into 33 3 times. 3 times 6 is 18. All right. Use the system of two linear equations graphed below to answer the question. What is the solution of the system of linear equations? Now you know the solution of the system of linear equations is where the two lines cross. So I'm willing to bet it's going to be at the next point. So here we have a slope, so it's down 2 over 3, so, and left 3, so down 2, 1, 2, 3. 1, 2, 1, 2, 3. Well, following this slope, this has a slope of 3, 2. So 1, 2, 3, 1, 2. So this goes through here, this goes through here, there's my solution. And that occurs at -5, comma, -4. Because remember, the x value goes first. So the answer is A. Is that the last question? Should double check. No. There were approximately 1.6 times 10 to the 11th pieces of mail processed in the United States Postal Service in 2012. This is about 75% of the number of pieces of mail processed in 2016. Now that has to do with the use of the internet. Less people are sending letters now. Approximately how many pieces of mail were processed by the United States Postal Service in 2016? So you know that 1.6 times 10 to the 11th is equal to 0.75 times something. Let's call that something x. So that means we'll divide both sides by 0.75. But wait a second, dividing by 0.75 is the exact same thing as multiplying by the reciprocal, right? And 0.75 is just a fancy way of saying 3/4, right? So really, I'm going to multiply by 4/3. So we have 1.6 times 10 to the 11th, and I'm going to multiply this by 4/3. Okay. So right now I know I'm going to end up with a number that is larger because I'm multiplying by 4/3, which is greater than 1. The only number in the answer choices that is larger than 1.6 times 10 to the 11th is I was about to say D. Alright, so let me reread the question. This is 75% of the number of pieces of process, so it has gone down. Approximately how many pieces of mail were processed by the United States Postal Service in 2006? Oh, so we need to have a number that is larger, right? Yep. That is very interesting. Yeah, the answer is D. That is the only possible answer. It is the only one that is larger. And using my calculator, so what I just did is I did 4/3 times 1.6. Sorry for the pause. Truth be told, I looked at my answer key and I read the wrong number. I looked at 45, which said A, and clearly A wasn't the right number. I'm like, oh my goodness, can't believe there's a mistake here. Did I make a mistake? Oh. Alright. Use the figure below to answer the question. A dilation of angle PQR will make the length of line segment Q prime R prime equal to 6 units. What is the measure of angle P prime, Q prime, R prime after the dilation? Well, here's the thing, folks. You know a dilation is going to give you a similar figure, and similar figures all have the same angle measurements, or else they wouldn't be similar. So that would not change the angle at all. Alright. Parker states that any function written without exponents must be linear. That is not true. Which function proves Parker's statement to be incorrect? We know that inverse variations, y is equal to k over x, or x times y is equal to k, does not have a exponent, but it is not linear. So we need to find an equation that looks like one of these. Well, this is a linear equation in slope-intercept form. This has an exponent, so I don't know why they put that there. This one, well, x over 3 is just the same as saying 1/3 times x, and that's okay. So that's our slope, so that's linear, slope of 1/3. Now this one looks just like this, except it's just raised it up 5 units on the grid. That's all. Alright, so instead of having an inverse variation that looked like this, it is going to look like this. It's been raised 5 units up. Alright, 49. I don't even know how to pronounce that. Ayan paid a $20 fee for a booth at an art fair so she could sell her ceramic bowls. She will earn $10 for every ceramic bowl she sells. The equation y equals 10x minus 20 represents the amount of money that, what's her name, will earn selling ceramic bowls at the art fair. Which graph represents the amount of money she could earn at the art fair? Alright, so we know that we have a positive slope and a negative y-intercept. This has a positive y-intercept and a negative slope. No! This one, again, negative slope, not so good. This one has a negative y-intercept and a positive slope. However, the slope here is 20, and our y-intercept is negative 10. Our original y-intercept is negative 20 with a slope of 10. Go back to this. There's my 10 and 1, or 20 divided by 2. And so this is the only correct answer. What is the solution to the equation? Alright, this is a simple train track problem, which we will do in the next video.